Hello guys, today we'll be learning about vectors. I'm going to be reviewing everything related to vectors that's going to be on my exam, hopefully on your exam too. It's probably going to be about 5 minutes each. I don't know how many parts I'm going to make, but hopefully not a lot. But there are a lot to cover, and I might get some things wrong, so yeah, let's get into it. So, well, first of all, I already talked about vectors in the previous video. But apparently in my book it says that, so it's like a two-dimensional vector v is determined by 2 points in the plane, an initial point P, also called tail or base point, and a terminal point Q, also called the head. Well, basically I said vectors are, it shows the length and the direction. Oh, not this paper. So hopefully you watched that video, because this video is a little more advanced. So one of the problems that's going to come out in the vector exam is going to be like something like, let's say this is like 30 degrees, and that's like 40 degrees. And we have like an object right there. And this object has like 100 kilogram, right? Well, we know that the gravity works on this box, so we can draw a free body diagram if you know how to draw it. Force 1, force 2, force 3. Now these are vectors, so you know, force 3, force 2. So you want to draw arrows on top. That. So acceleration for this gravity is 0, negative 9.81. You put negative because it's a direction, it's going down. So let's see F3. That would be 0, negative 981. Well, how do we get negative 981? That's because we multiply 100 onto negative 9.81, because we want to multiply because we want to make it a force, right? So the force of the weight would be mass times the acceleration. So yeah, force of the weight. So mass is 100 and acceleration is negative 9.81. And also, from looking at how the box is not moving and is stationary, we can say that F1, F2, F3 equals to 0, because it's stationary, it's not moving. Now the next thing we want to do is we want to have a unit vector. So our unit vector is going to be, I'm just going to write it as U arrow, and then it's going to be cosine theta and sine theta. Now, I'll tell you, well, I hope you guys know why it's the cosine theta and sine theta. Well, to just basically explain why, well, if we do cosine theta, because we're going to have an invisible horizontal line right there, and we're going to calculate, like for cosine, this part is the x, and this part's the y, change in y, change in x, change in y, change in x. When we do, let's say we have an angle over here. We're calculating that. That's 40 degrees. And the cosine of 40 degrees would be this over here. So it's going along the x-axis. While when we do sine, we're doing vertical movement. So that's how we get cosine and sine. Let's keep going through it. So, need more space. Don't worry, I'll write it back again. I just need more space on this board. So we wrote that U is cosine and sine, and force of 3 equals to 0, negative 981. And the drawing basically looks like this. 30 degrees, 40 degrees, object. Okay. So now we don't want to have thetas, you know? Like we want to have an angle. So how do we find an angle? Well, again, I said that we have an invisible line right there. And these two lines are parallel. So what does it tell you? This is 30 degrees, and this would be 150 degrees, right? So for U1, it's going to be the unit vector for this angle. So U1 would equal to cosine 150 degrees and sine 150 degrees. While on the other hand, U2, which was going to be 40 degrees right there, that's going to be 40 degrees. So it's just going to be cosine 40 degrees and sine 40 degrees. Cool. Now what do we do next? Well, we want to multiply all these things together. Why? Because we already know force 1 plus force 2 plus force 3 equals 0. So what is force 1? Well, force 1 is a unit vector of its force 1. So that's force 1, that's force 2, and that's force 3. Force 1 is a unit vector times, let's see, force 1, yeah. Force 1. This is the magnitude, if you watched the previous. And then U2 times magnitude of force 2 plus 0, negative 981 equals 0, 0. Now, we can again expand this and say it's cosine 150 degrees, sine 150 degrees, F1 plus cosine 40 degrees, sine 40 degrees times F2 plus 0, negative 981 equals 0, 0. I'm going to erase this part because we already have that down now. Oh, I wanted to erase that one. Okay. Let's see. What is cosine 150? Well, we gotta find that out. You gotta use our calculator, and so make sure your mode's in degrees mode. I got cosine 150 is negative 0.86. Sine 150 is 0.5 plus cosine 40 is 0.76 and sine 40 is 0.64. And then 0, negative 1 equals 0. Now we have two variables. We can make two equations with this one equation. So it's gonna look like this: negative 0.86 force F1 plus 0.76 force 2 plus 0 equals 0. Next one will be 0.5 force 1 plus 0.64 negative 981 equals 0. So you got two equations, 1, 2. You got two variables, and I think you can now solve for force 1 and force 2, which is going to be pretty simple. So the next concept that we're going to talk about is going to be vectors and the starting position, because on the last video when I talked about vectors, I told you guys vectors can start anywhere, but in math we say it starts at the origin. But now it gives us where it starts. So that equation is vectors t equals a plus t b. So apparently a is the position vector of any point on time on the line. Okay, so A is basically the position and B is the vectors. So when we have a coordinate like that, so we go to A, and from there we draw our vector. Just gonna be like A.